So on some previous slides, we looked at how the tangential velocity of an object was tangent to the circular path, and the acceleration was sort of pointed towards the center. So that's fine. Those are vector quantities. We need to pay attention to the direction of those quantities, but we also need to look at the magnitude. So the magnitude of this kind of acceleration depends on both the tangential speed and the radius of curvature, and we can find its magnitude by taking the speed, squaring it, and dividing it by the radius of that circular motion. So it depends on those two things. Now the derivation for that equation is quite difficult to go through, so I'm not going to do that here. But let's take that as sort of a given here. Let's just look at some proportionalities. We can say that a sub c is proportional to, so I'm using that symbol alpha to mean proportional, it's proportional to the square of the speed. So if I double the speed at which an object moves through a circle, that corresponds to an increase of a fourfold increase in the centripetal acceleration. So doubling the speed quadruples the acceleration. Okay, so it's proportional to the square of that speed. Now a sub c is also proportional to 1 over the radius. So this is an inverse proportion. If I double the radius for an object moving through a circle, double the radius causes a halving, corresponds to halving the acceleration. So we can just look at proportions there. Now, we have some other equations that we can look at. For an object that's moving through a circle, let's use a different color here. For an object that's traveling through a circle, we know that the distance that that object can travel around that circle, or the distance rather that it travels, is called the circumference. If we consider the speed as distance over time, we can look at that distance as the circumference of that circle. And that time, I'm going to use a special time called the period. So the period of that rotation. Period is the amount of time to complete one cycle. So in one cycle, we travel a circumference of distance. That period would be the time it takes to do that. Now, we have a way of determining that circumference. Let's replace speed with v tangential. So that's the tangential speed that it has at various points along that circle. And let's replace the circumference now with 2 pi times the radius, and then divide that by t, where t represents the period of that motion. So that equation is another useful one. It tells us how we can find the tangential speed based on the radius of that motion and the period. Now I want to derive for you another equation that combines these two. So I'm going to take this equation and combine it with this equation. And I'm going to do that by replacing this value. I'm going to replace v tangential with this value here. So I'm just going to do a little substitution here. And we're going to derive another equation for a sub c. So the derivation, I'm going to take a sub c, and instead of it being v squared over r, I'm going to replace v squared over r with 2 pi r over the period squared all over the radius. So again, just using some color coding so it's easier to follow, this right here is my tangential velocity. I found that over here, and I'm just substituting that in the appropriate place. Now let's go ahead and clean this up, do some algebra, and see if we can't clean this up. Well, I'm squaring this thing in parentheses. That means every term becomes squared. So 2 becomes 4, pi becomes pi squared, r becomes r squared, t becomes t squared, and then I'm dividing by r. Now this is a fraction within a fraction. We do see that the numerator of this fraction, and that's in the denominator, that there's an r squared in the numerator and an r in the denominator here. We can actually cross off then, to make this a little bit easier. We can cross off one of those squares one of those r's in the numerator with that r in the denominator, and we get this nice equation, another equation that we can use to calculate the centripetal acceleration, 4 pi squared r over t squared. So these equations, I have them sort of circled here. These equations are equations that are used to describe the kinematics of circular motion. V tangential, how far an object travels, circumference divided by the period. Centripetal acceleration, always pointed inward, and we can find it via those two equations.